All right, it is day 3 of distance learning. Happy Friday to my A-Day students, and if you're in my B-Day, then you're watching this on Monday. So happy Monday to you. So again, it's day 3, A-Day. This is April 3rd, and then B-Day, April 6th that you're watching this. Sorry, B-Day, I'll change the joke next class for Wednesday. So our last 2 videos we created were units that we've already gone over. We were just refreshing and reviewing skills. This is the last day of review, and then on Tuesday and Wednesday we're going to start diving into some new stuff. So our last unit of review is on functions. We spent a lot of time talking about them this year. The 4 forms of a function, including the equation. We've talked about graphs of functions and all of its extrema. But for today, we're going to focus on our definition of what a function is. So again, if you need to freeze this video or pause this video, do that now. If you need to jot down our definitions, please do that. So a function, it's a relation where each input has exactly one output. And we looked at examples in class, like a vending machine. If you pressed one button, you should always get that one thing back out. We also looked at the students in our class and our ages, right? Your age can only be one number at a certain time. And it's totally fine for 2 students to be the same age at the same time. So we'll talk about that in a second. 2 other important definitions that we need to remember. Domain, that's the set of all possible inputs. That's the X value, the number that comes first, whether it's in a mapping, an ordered pair, or in a table. And then our range is similar to the domain, but it's the set of all of the possible outputs, all of the Y values. That's the second number in our mapping, in our ordered pairs, and in our table. So again, if you need to go back and pause this, please do so. I will hang them up on our interactive wall for us. There we go. So we're going to take a look at 3 examples before diving into a little bit about function notation. So example 1, we have a mapping here. So it says, is it a function? And if it is, you're going to give the domain and range. If it's not, then you're going to give a reason why it's not. So here we have a mapping. We have -3, 4, 5, and 10 in the first oval. And we have -2, 10, and 11 in the second oval. I could see a mapping from -3 to 10, from 4 to -2, from 5 to 10, and from 10 to 11. So in class, we talked about a lot of examples like this. This one is an example of a function. So yes, it is. And that's because each of my inputs only has one output. It is totally fine that 10, the output 10, has -3 as an input and 5. Remember, 2 students can be the same age at the same time. So since it is, we're going to make a list of our domain. Don't forget, domain, the set of all the possible X values, all the first values. So -3 is used in our domain. 4, 5, and 10. So that makes up our domain. Our range would be the set of all the possible Y values. Coming from the second oval, we have -2, 10, and 11. So that's our first example. Yes, this one is a function. Each input has exactly one output. Our domain would be the set of all the inputs. Our range would be the set of all the outputs. We're going to take a look at number 2. This time, instead of having a mapping, I have a set of ordered pairs. There are 3 ordered pairs here, and the way I like to tackle a problem like this is looking at all of my X values. So I like to underline all of my inputs because that tells me whether or not this is a function. So if I have 3 mapping to 4 and 3 mapping to 5, this is not a function. So no, this is an example of a relation that's not a function. And the reason would be the input 3 has more than one output. And because it's not a function, we do not need to list the domain and range because it's not a function. And then lastly, our example 3, we have a table, and again, our X values are in line with our Y values, so similar to a mapping, but we don't need the arrows, right? So we're looking straight across. So 5 maps to 1, 7 to 1, 9 to 1. This is one that we found tricky in class, but remember, it's okay for multiple students to be the same age at the same time. So this one is also a function. And again, each of our inputs always has only one output. And our domain is actually again, the list of all of your inputs, 5, 7, and 9. And our range is actually only one number, 1. I don't need to write that 3 times because 1 is the same thing as 1. So those are 3 examples that you should have written down at this time. We are going to talk about one last piece using our function notation. So don't forget function notation. It's just a fancy representation of the equation y equals mx plus b, right? This f of x has replaced where the y variable was. Our x still represents any value that we're inputting into our function. And this whole thing, remember, this is not f times x, this is f of x. This is the value of our function when I plug in whatever number it is for x. So this whole thing represents my output. So if I were to give you an example like this, f of x equals 3x plus 2, right? 3 would be the thing happening over and over again, the pattern. And then 2 would be that one-time fee, or that one-time thing you have to pay, or where something starts. So if I asked you to find f of, 5 in this case, what that means is if this x was replaced by 5, then this x would also be replaced by 5. So I've substituted 5 into my function. So f of 5 again is just my notation. So my value of my function when I input 5 would be 3 times 5, which is 15, plus 2, which is 17. So when my input is 5, my output is 17. That's what function notation is used for. You can also have an example using function notation where they ask you to find x if f of x is equal to 8. So if it's written like this, we are looking for what our input is, but if you notice that whole f of x is listed as, or is represented by the number 8. That means this whole 8 replaces my output. So when I replace f of x with 8, my equation looks like 8 is equal to 3. I'm going to leave that x there because I don't know what x is. I'm looking for my input, plus 2. And then I could solve that equation like I would any two-step equation. Inverse operations, subtract 2 on both sides. And then I need to divide both sides by 3. I ran out of space, so it would be 2 is equal to x. And so what that means for me is my input, when my output is 8, is 2. And I can write that using function notation. F of my new input, 2, is equal to still my output, 8. So that is our very quick refresher on functions. I know there was a lot in this unit. It includes graphs. Don't forget about your vertical line test when you're testing to see if a graph is a function or not. And this was our last day of review because on Tuesday for A Day and Wednesday for B Day, we're going to be looking at brand new stuff. So if you haven't been watching these videos, you really should. If you haven't been taking notes on the new one, I'm going to require you to take some notes because your quizzes is not going to be stuff that we've learned already in class. It's going to be brand new stuff. So enjoy your weekend if you're A Day, and if it's B Day, happy Monday. All right?